Hi students, in this video we are going to see about program flow mechanism. What is meant by program flow mechanism? What it says? It's nothing but when you are going to run a program, when you are going to execute a program, in what basis the execution of a program is carried out. Whether it follows any control over there or it only based in the execution is only based on the data and operands given in this execution, or it may demand for any reduction in systems. So here when you say simple example is when you are going to execute one C program which involves some mathematical operators or something, mathematical calculator, right? So what is the basic nature of that execution? Based on the user input, what he wants to do operation, whether he wants to do plus or minus or addition or subtraction, based on its input, the data, the program will keep on executing. So we can say that that program is executed on the basis of the data given. Okay. Say for example, you are going to check whether the number is prime or not. That program, how it will be executed? You will be giving only one input. Based on that input, your control is to check whether the number is prime or not. So what you will do? You will keep on checking whether the number is prime or not. You will be having one condition statements to check whether the number. So that execution of that program will be purely based on the control or conditions. So that kind of execution will be, we can say that kind of mechanism is called a control flow mechanism. In some cases, in few cases only, based on the demand, that reduction in models, that mechanism is different. But the famous flow of programs are based either control flow mechanism or data flow mechanisms. So likewise, this program flow mechanism is divided into three parts, three categories, not parts: control flow mechanism, data driven mechanism and demand driven mechanisms. So here control flow mechanisms will be used in a conventional computers. Say for example, uniprocessor, von Neumann architecture, very traditional systems, these control flow mechanisms will be used. And data driven mechanisms used by data flow computers, like some transactional systems or all scientific calculation systems. If you want to operate more operands, that kind of computers will be, that kind of softwares will be executed based on the data driven mechanisms. And demand driven mechanisms is mainly purely used in reduction computers. Very few cases only this demand driven mechanism will be carried out. Okay, so now I hope you understand what is meant by control flow mechanisms, data driven mechanisms and demand driven mechanisms. Let us see one by one in detail. What is meant by control flow mechanism means conventional von Neumann computers uses a program counter to sequence the execution of instruction in a program. In traditional von Neumann computer, we know the term called as program counter, PC. So what is the nature of the PC? PC is the primary element in the control unit. It only keep on the current execution instruction. So based on the program counter operations only, the instructions will be keep on executing. So here the program counter is a sequential execution style. This is a sequential execution style. This is mainly used in uniprocessor systems. It is not applicable in multiprocessors, but mainly used in uniprocessor systems. This control flow computers uses shared memory to hold instructions and data objects. So this control flow computers uses a shared memory and all shared to hold program instructions and data objects. Okay, so this is what about control flow mechanism. The next one is data driven mechanisms. The data flow computers are based on a data driven mechanisms which allows the execution of any instruction to be driven by data. That means if the data is available, the operand is ready to execute, means the based on its condition only the instructions will be executed. As I already told that writing a simple calculator program and executing that program is purely based on the data which you are giving as input. So if you fail to give the input, that operations will not be carried out, that execution will not be successful. So this kind of program execution, this kind of purely based on data executions will fall in this category, data-driven mechanisms. This data flow computers embeds the high degree of parallelism at a fine-grained instruction level. Yes, obviously, at the fine-grained instruction level, we can achieve more parallelisms in case of data-driven mechanisms, right? That data flow machines have high potential for parallelism and throughput and freedom from side effects, but have high control overhead, lose time, waiting for unneeded arguments, and difficult in manipulating the data structures. Okay, this data flow mechanism have high potential for parallelism and throughput from freedom from side effects, but it have high control overhead. Okay, so this is what about data driven mechanism. Now we are going to summarize the three flow mechanisms. What is meant by control flow, data flow and reduction flow. First definition is conventional computation token of control, and token of control indicates when a statement should be executed. Okay, so when a statement should be executed. The data flow mechanism, eager evaluation statements are executed when all their operands are available. This is the basic definition of data flow. And third one is reduction control, reduction computers, and this definition is lazy evaluation statements, and this lazy evaluation statements are executed only when their results is required for another computation. This lazy evaluation statements are executed only when their result is required for another computation. That means it is somewhat similar to resource conflict. Resource conflicts means when you are executing the two parallel programs, if one of the resources required in the another program, another process, means that situation is called as resource conflict. So here in demand driven, that the same concept is going to apply. This lazy evaluation statements are executed only when the result is required by the another computation. Okay, so what may be the advantages? So in control flow we can say that it is a full control and most successful models. In data flow it is very much potential for the parallelism, but in the demand driven only required instruction, because only when the time of resource conflict occurs, when the computation depends on the another execution, means that kind of required instructions only can be executable. Okay, then what is meant by disadvantages? But in control flow less efficient, that is because it is a traditional model, very uniprocessor model only it's used, so that's what this is very less efficient than other two. But in data flow, time lost waiting for unneeded arguments, time will be wasted, time will be lost waiting for unneeded, unrequired arguments. So that time, the time will be lost. So it may leads to more time for the execution. That is also not good for good quality of parallelism. And then third, that means reduction level does not support sharing of objects when changing local state, because it will not be useful for in the shared memory concepts. like if that is resource conflicts, no. So when you take one processor is required, it requires the resource from another processor, means that situation is called as resource conflict. So at that time it will not support the sharing of objects in by with the changing in local states. Okay, so that means that it will not allow the sharing of objects. So these are the some of the advantages and disadvantages in each category. Okay, I hope you understand this video. I'll catch you in the next